Big shout out to Vincent Barbon. All right, yay. Okay, yeah, you guys don't know because you're not here, but that's all right. We have two equations here that represent two planes, and maybe this is Rebecca's homework, and maybe this is Nicole's homework. Notice I picked two people from two different classes. Wasn't that nice of me? Yeah, I'm good. So maybe they're checking to see if it's right, and they just don't know. Well, what we're going to do is find a method of doing that. The first thing I would do is I'd say, well, let's determine the normals. That's the low-hanging fruit. If the normals are not scalar multiples, then your planes are not parallel. They're going to have to be like that, in which case they are not the same plane. So let's go after the normals. We're going to say check normals. So normal 1 is going to be given by -1, 5, 2 cross, well, it's 2, 4, 2. Why don't I make it 1, 2, 1? Normal 2 is going to be equal to 1, 2, 1. And this one's going to be cross 1, -5, -2. Do you see what I see? I could change the direction of this one. I've never noticed this before, but I'm done. Come on, the cross of these two vectors, and oh, well, hold on. Let's be honest. The cross of these two vectors will, in fact, be a different vector than the cross of these two vectors. They'll be going in opposite direction, won't they? But they will be scalar multiples of each other, won't they? So this normal will be equal to -1 normal 2, which satisfies, did I say collinear? I don't want, the normals are collinear. Therefore, the planes are parallel. And I would say are at least parallel, because it doesn't mean that they are the same plane at the moment. It just means we've got something like this going on. They're parallel. What do you think of that? You like that? So now I have to prove that they're not like that, but like that. And one way to do that might be to take a point from one and prove that it lies in the other. Okay, so let's change one of them to parametrics. X equals 0, -r plus 2s. Y equals 3 plus 5r plus 4s. Z equals 2 plus 2r plus 2s. I'm going to look to my audience. Did I make a mistake? Again, these things are kind of blurry to me. Are we focused? Are you guys okay? Is that better? Okay. So now what we're going to do is we're going to assume the point on the other plane lies on plane 1. So when we assume this, what we're going to say is x equals x, y equals y, z equals z. So we're going to take -2. We're going to sub -2, 6, 3 into the parametrics. So we're going to end up, coming up, sorry, tell me when I'm off the screen, kids. It's going to be -2 equals -r plus 2s. It's going to be, they'll call that equation 1. It's going to be 6 equals 3 plus 5r plus 4s. Careful with what your 5's and s's are. 2, and my third equation is z equals, oh, not z. I have a value for z. It's 3. 3 equals 2 plus 2r plus 2s. Those are your three equations. They're what I call my elimination equations. We can make them look nicer. Let's make r positive and s is negative. So it'll be r minus 2s equals 2. That's equation 1. Equation 2 will be 5r plus 4s equals 3. And equation 3 will be 2r plus 2s equals 1. Questions? Ask.
No.
You okay? So now you got to choose two of those to work with. Which one do you want to work with, kids? 1 and 2. Work with 1 and 2. So what you're going to do is you're going to find the r and the z values for which x equals x and y equals y. You're finding the parametric values of r and s such that x equals x and y equals y, because that's what equation 1 represents, x equals x, and this represents y equals y. So you're going to have r minus 2s equals 2. You're going to have 5r plus 4s equals 3. What do you want to get rid of? R's or s's?
Yes.
Okay, so that means I got to multiply this one by 2, right? So it's going to be 2r minus 4s equals 4. This is going to be 5r plus 4s equals 3. Bracket, bracket, line. What do I need to do to get rid of the s's? We need to add them. I think this is the first time I've added. That's good. And we're adding because the signs are different. So 2r plus 5r is 7r. Negative 4s plus 4s is no more s's. 4 plus 3 is 7. Lo and behold, r equals 1. Take this and sub into 1 or 2. Not the third one. Leave that one separate. So let's sub it into 1. And we're going to get 1 minus 2s equals 2. So we take that over, that's going to be 1. So I think s is equal to negative 1/2. Do we agree? Okay. So these are the values of s and r such that x equals x and y equals y. Very good. But we now need to know, for those values, will z equal z? Check that z equals z for these values of r and s. So what we do is we take 2, and we're supposed to put in a 1 for r, plus 2, which is negative 1/2 for s, and that's supposed to equal 1. That is 2, subtract 1 equals 1. 1 equals 1. That means that our math worked out, which means that our assumption worked out, which means that the point lies on the line. Not the line, plane. Not on the plane, but it actually lies on both planes because we took it from the other plane. So now we need a concluding statement that says, since planes are parallel and share one point, this means they share every point and represent the same plane. So once again, remembering what this problem was, this was Nicole and, who did I say? Nicole and Rebecca checking their homework to see if it's right. What we know is either Rebecca and Nicole are correct or they're both wrong. So that's what you know so far. Very cool. Let's do the same question using another method. I'll come right back.